Okay, so today we want to work on a Frere model to find out multiplication, and we're going to be doing 23 times 12, excuse the glare there if it gets really bad. And I've done the picture version of this, and during the video here, you may have to forgive me because I might be going off of the script here a little bit. This may not be 100% what you want, but I found a method that I believe is pretty analogous to a Frere model. I think it is a Frere model from what people have told me, and I just want to try it out because it's so freaking cool. Right? So, Dwayne, you'll have to, forgive me for any liberties I might take here, but I'm going to run with this with the way that I was told. And I think I talked about this in another video. The Japanese method is what I was called. I don't know if that's actually the name of it, but that's how it was explained to me, is that a lot of students in countries like Japan practice a method that's a little bit similar to this, but they do it through a visual representation that's kind of cool. So what they do is they take our numbers here and we break them down into lines here based off of what their place unit is here, so the 2 and the 3. So first off, we're going to draw some diagonal lines here for our 2, the first digit there, right? So we've got those drawn out. And then we're going to represent our second number, 3, right there. So we're going to put a space in between these, and we are going to do 3 more lines, okay? So this is our representation of 23. I think this is really, really cool how this works out. If it works out, I may completely mess this up, but I think I've kind of got it down well enough that I sort of understand how it works. Then the same thing we're going to do here with our other 2 numbers, starting with our first digit here, but instead we're going to make crosshatch lines. We're going to go in the other direction. We're going to start and move from left to right like we did before here. So starting at the bottom here, we're going to say 1. So we're going to draw right across there to make all these intersections. And then again, for the 12, the second digit is a 2. And now what we're going to do is we're going to say that we've broken this down into zones. We made a cute little box here, and I'm going to say that we've broken this down into zones here, right? This is the intersecting part right here with the numbers in the middle. This is our beginning digit. This is our ending digit. And what we're going to do is we're going to just look for how many intersections do we have here. So starting here, I'm going to start with, let's start with triangles to mark our points here. We have 2 triangles where we have the 2 intersections here. Up here, let's say we go to, we'll change to squares. We have 1, 2, 3, 4 squares. And then down here in the second part of the zone where these intersect, 1, 2, 3. Okay, so 4 at the top, 3 at the bottom. And then over here, if we look here, we'll go to, I guess, circles on this one. We haven't used those yet. And go 1, 2, 3, 4, 5, 6 intersections. So now if we count these up in the different zones, starting over here, we have 6 circles. Then over here, we can count 1, 2, 3, 4, 5, 6, 7 of the squares. And then over here, we have 2 of the individual triangles. So 2, 7, 6 is what we get. And if we go back to our algorithm here and we check this, 3 times 2 is going to give us 6. 2 times 2 is going to give us 4. 1 times 3 moving over is going to give us 3. 1 times 2 is 2. Add these all up and we get 276, which works out. And I think that's super, super neat.